Good morning, everyone. In this video, we are going to continue with chapter 6, triangles. We had seen basic proportionality theorem in the previous video. Now, let's move on to criteria for similarity of triangles. You have studied for congruency criteria, SAS, SSS, etc. Same way, there are criteria for similarity also. So let us see all those theorems. The statements we are seeing first, but when you are proving it, you will be just using the short form, same as how you had been doing for congruency. Okay, so theorem 6.3 is triple A. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio and hence two triangles are similar. That means if the angles are equal, then the sides will be proportional. So it is enough to prove that three angles are equal. And this criterion is referred to as AAA criterion for similarity of two triangles. Now, we know that for a triangle, total angle is 180 degree. If two angles are equal, then by angle sum property of the triangle, we can say that the third angle is going to be equal whatsoever. So, it is not necessary to prove all three angles to be equal. If you can prove just two angles to be equal, even that would suffice for similarity. So, if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. So this is referred to as AA similarity criterion. So this is what we'll be mostly using because it is enough to prove just two angles to be equal. Now, moving on to theorem 6.4, SSS, which you had already for congruency also. So if in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. Only difference between congruency and similarity is the sides are going to be proportional in similarity and they are going to be equal in congruency. So note that though it looks the same, SSS similarity, but here the sides have to be proportional. If the sides are proportional, then the angles will automatically be equal. So therefore, these two triangles will be similar. Okay. SAS. So whenever side is involved in the criteria, we mean that the sides are proportional in similar triangles. So if one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then two triangles are similar. It is referred to as SAS criterion. Okay, now with all these criterion, let us move on to exercise 6.3, question number 4. In the figure, QR by QS is equal to QT by PR and angle 1 and angle 2 are equal. We have to show that triangle PQS is similar to triangle TQR. So given that QR by QS is equal to QT by PR and angle 1 and angle 2 are equal, now to prove these two triangles, that is PQS, inclusive angle is there. Okay, PQ we don't have, QS we have in the given. And angle 2, inclusive sides PR and QR, both the sides are there. Okay, but one more what we don't have is QS and QT is given to us. We need QP. So with the given, we are going to prove. For that, in triangle PQR, this triangle we take angle PQR and angle PRQ, that is angle 1 and 2 are equal. So therefore PQ and PR are going to be equal because sides opposite to equal angles are equal. Now it is given already that QR by QS is equal to QT by PR. So we are going to take instead of PR as PQ because PR and PQ are equal from the first equation. So using that equation, we get QR by QS is equal to QT by QP. Now in triangle PQS and TQR, so the small triangle and the whole triangle we are considering, QR by QS is equal to QT by QP. So the sides are proportional and angle Q is equal to angle Q, that is common angle. So angle and sides inclusive are proportional, angle is a common angle. Therefore, triangle PQS is similar to triangle TQR by SAS similarity criterion. Don't just leave it as SAS because we already have the same with congruency also, isn't it? So when you simply write SAS, it is understood to be congruency condition, and for similarity, you have to mention that SAS similarity criterion. Okay. Now, moving on to the sixth question. In the figure, if triangle ABE is congruent to triangle ACD, we have to show that ADE and ABC, the small triangle and the big triangle, are similar to each other. So given that two triangles are congruent, we have to prove another two triangles are similar. So ABE and ACD are congruent. To prove ADE similar to triangle ABC. Now proof, we know that ABE and ACD are congruent. So by CPCT, which means corresponding parts of congruent triangles, we can say that AB and AC are equal and AD and AE are also equal. So that will be the first two equations for us. Now in triangle ADE and ABC, dividing equation 2 by 1, we get AD by AB equal to AE by AC. AD by AB equal to AE by AC, and angle A is equal, which is a common angle. So we can say that triangle ADE is similar to triangle ABC, again by SAS similarity criterion. Moving on to question number 7. In the figure, altitudes AD and CE of triangle ABC intersect each other at the point P. We have to show 4 points we have to show over here. Triangle AEP is similar to triangle CDP. Triangle ABD is similar to triangle CBE. Triangle AEP is similar to triangle ADB. Triangle PDC is similar to triangle BEC. Now, first let us consider triangle AEP and CDP. Okay, so these two triangles we have to consider for now. Okay, now angle AEP, this angle is equal to CDP. They are all 90 degree, and APE is equal to angle CPD, which is vertically opposite angles. So hence AEP is similar to triangle CDP. Okay. So we have these two angles to be 90 degree. These two are vertically opposite angles. So this triangle and this triangle are similar by AA similarity criterion. Okay. Now for the second part, what we are having is triangle ABD. ABD, that is this whole triangle we have, and triangle CBE. CBE, that is this part of the triangle we are having. Okay. So first we have completely this one, and then we are going to have CBE. Okay. Now for this, we are having ADB 90 degree and CEB 90 degree. ABD and CBE, that is angle B. This angle is a common angle. One is 90 degree, another is B common angle. Therefore, triangle ABD is similar to triangle CBE. Again, by AA similarity criteria. Now, for the third type, we have triangle AEP and triangle ADB. This triangle, and we are having ADB. So ADB, the bigger one also. So this is a common part which we are having over here. Okay, now for this one, what we are going to have is angle E is 90 degree. Again, angle D is 90 degree. Angle PAE. So A is the common one over here. Okay. So angle A is common. The previous one, angle B was common. Same way over here, angle A is common. So again, by AA similarity criterion, we can say triangle AEP and triangle ADB are similar. Again, the fourth part, we are having triangle PDC, that is the smaller one, and then we are having triangle BEC. BEC, so the bigger one. Again, we are having a common one. Okay, so over here we are having PDC, that is D 90 degree, BEC again E 90 degree we are having. So, and then the next one will be angle C, which is the common one for us. Okay, so angle C if we are taking, then we can prove again by AA similarity triangle PDC, the smaller one, and BEC, the bigger triangles, are similar by AA similarity criteria. So all four parts we have proved. Now question number 8. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE and CFB are similar. So given that E is a point on AD produced of the parallelogram ABCD at the point F and BC BE intersects CD at the point F. We have to prove that triangle ABE and triangle CFB are similar. Now for that, angle A and angle C are equal because they are opposite sides of a parallelogram. ABCD is a parallelogram, opposite angles are equal, so angle A is equal to angle C. Now the next one, angle AEB, AEB and CBF are equal. These two angles are equal because they are alternate interior angles wherein AE is parallel to BC. We are taking BE to be the transversal. So E and this part of B will be equal. So by AA similarity criteria, we can say that triangle ABE is similar to triangle CFB. Moving on to question number 9. In the figure, ABC and AMP are two right triangles, right angled at B and M respectively. We have to prove that triangle ABC is similar to triangle AMP and CA by PA is equal to BC by MP. Now, let us move on to the proof. So over here, we are having triangle ABC and AMP. Now, B and M are 90 degree. It's already given that they are two right angle triangles. And angle A is a common angle over here. So we can say that triangle ABC is similar to triangle AMP by AA similarity criteria. Now, since these two sides are, these two triangles are similar, we can say that CA by PA is equal to BC by MP, but because they are corresponding sides of similar triangles. Now, moving on to question number 10. CD and GH are respectively bisectors of angle ACB and EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG, we have to show three parts. CD by GH equal to AC by FG. DCB is similar to HGE. DCA is similar to HGF. So we are writing given and to prove all the points. Then we move on to the proof. It is given that in triangle ABC, that is a whole triangle, and FEG, again the whole triangle, are similar. So the corresponding angles will be equal. That is, A will be equal to F, B will be equal to E, and C will be equal to G, the whole angle. Now, since ACB is equal to FGE, that is C and EG are equal, so their angle bisectors will also be equal. Angle bisector means cutting the angle into half. So if the angle as a whole are equal, half the angles are going to be equal. So we can say that ACD and FGH are equal and DCB and HGE, that is the half part of those two, are also equal. This part is equal and then this part is also equal. Okay. So now in triangle ACD and triangle FGH, these two triangle, the upper part when we take, angle A and angle F are already equal and bisectors are also equal. So by AA similarity criterion, we can say that these two triangles are similar. That is ACD is similar to FGH, and we can say that CD by GH will be equal to AC by FG. Now, again in triangle DCB and HGE, C and G, the angle bisectors, half of the angles are equal. B and E are equal, we already know. So therefore, these two triangles, that is DCB and HEG, are also similar by AA similarity criteria. Again, considering triangle DCA and HGF, we can say that A and F are equal. So therefore, half angles are equal and these two triangles are similar. We are already seen that. Now, moving on to question number 11. In the figure, E is a point on the side CB produced of an isosceles triangle ABC. So we have ABC isosceles triangle, we are producing it, and E is an external point. AB is equal to AC is given, AD is perpendicular to BC, and EF is perpendicular to AC. We have to prove that ABD is similar to ECF. So for this, let us, after writing given and to prove, we'll move on to the proof. It is given that ABC is an isosceles triangle. AB is equal to AC. So angles opposite to equal sides are equal. So angle B and angle C will also be equal. That's the first equation for us. Now in triangle ABD and ECF. So this triangle and ECF, the one lying down type, those two triangles we are going to consider. Here D is 90 degree and F is also 90 degree. So these two angles are equal. And BAD, this angle, and CEF are equal from the first equation. So therefore, triangle ABD is similar to triangle ECF by AA similarity criteria. That's all. We have proved it. Now, question number 13. D is a point on the side BC of a triangle ABC such that ADC and BAC are equal. We have to show that CA square is equal to CB into CD. So which is equal? ADC, that is this angle, is equal to BAC, that is this angle. These two are equal is given to us, and we have to prove that CA square, that is this side, is equal to CB into CD. Okay. Now, in order to prove that, okay, so now it's given that ADC and BCA are equal, and ACD and BCA are also common angle. So therefore, triangle ADC is similar to triangle BAC by AA similarity criterion. And from them, we can say that the sides will be proportional. So CA by CB will be equal to CD by CA. When we cross multiply them, we get CA square is equal to CB into CD, which we have to prove. So with this, we have come to the end of this session. We'll continue in the next video. Thank you.